All right, in this lesson, we are going to revisit linear quadratic systems. This time, we are looking at application problems, and we are going to be using technology, which for us is the TI-84 calculator. And so a quick review, we can solve linear quadratic systems by graphing. And so with a linear quadratic system, one of your equations is a line, hence linear. The other is a parabola, that's the quadratic piece. Okay, and so for my first equation, it's y equals negative x squared plus 3 or minus 3. And so I know my y-intercept is negative 3. And then we know it's opening down because of the a value of negative 1. And so we also need to know either the vertex or the axis of symmetry, the roots, something else other than just the y-intercept. And so it might be helpful to factor this to get the x-intercepts. And so the first thing I would do is factor out the negative. And then two numbers that multiply to 3 but add to negative 4 are negative 1 and negative 3. And so that means my roots or my x-intercepts are at 1 and 3. And so 1 and 3. And so since my a value is 1, that would put the vertex right in the middle of these two and then just up 1 unit. And so we can use the symmetry to plot another point. And so there's my quadratic function. Okay, for the linear function, we need to move the x to the other side to get mx plus b. So that means my slope is negative 1 and my y-intercept is positive 1. So starting with the y-intercept, and then the slope of negative 1 would be down 1, right 1. There's one of our solutions. Down 1, right 1, down 1, right 1, and there's our other solution. So we can connect our line, and then solutions are the ordered pairs where these functions intersect. So we have two solutions. One of them is 1, 0, the x-intercept, and the other is 3, negative 3. Okay, and so to verify these solutions, we can plug them back into our original equations. And so starting with 1, 0, 1 would be our x, 0 would be our y. And so looking at the quadratic, 0 equals negative x squared minus 4x minus 3, filling in the 1 for x. That would give us negative 1 minus 4 minus 3. Negative 1 plus 4, sorry. Negative 1 plus 4. That's the original equation. And so 0 equals 3 minus 3. 0 equals 0. It satisfies the quadratic equation. And then looking at the linear equation, which is x plus y equals 1. So x plus y equals 1 satisfies that equation as well. And so we could also check the 3, negative 3. I'm not going to plug them in, but you would just plug them into both equations to make sure they end up with either like a 0 equals 0 or 1 equals 1. You should have a true equation when you plug those in. Okay, and so using the calculator, we can graph both of our equations as long as they're in y equals. So in your calculator, you have a y equals button. So you're going to press y equals, and you're going to type your two equations. So 2x minus 15 is my first equation. X squared minus 6x is my second. And then you should see a graph that has your quadratic and your line. And so once you have your quadratic and your line, you're going to press second, trace 5, and then it's going to ask you for a left bound. And so just make sure your left bound is somewhere to the left of your intersection point and press enter. And then it's going to ask you for a right bound. make sure it's to the right of the intersection you want, and press enter. And then it's going to ask you to guess. So just get as close as you can to the intersection and then press enter a third time. On my app, I don't need to do that, but you will. And so the intersection here is 3, -9. Okay, and so on this next example, it says use linear quadratic regressions to write the system for the graph. And so if it's harder to write the equations for a linear regression, you just need 2 points on your line. And so here I'm picking the actual solutions, but it can be any 2 points on the line. And so I have the point 1, -2, and the point 4, 4. And so 1, -2, 4, 4. For a quadratic regression, you need 3 points on your parabola. And so the 2 points I chose, these are points on the parabola as well. I just need a third point. And so I'm going to keep the points I had, 1, -2, and then 4, 4. And then a third point is the vertex, or whichever point you want to use, 2, -4. Okay, and so in your calculator, you're going to press Stat Edit. Okay, Stat Edit, and you're going to put your X's in L1, so 1, 4, and you're going to put your Y's in L2, -2, just those 2 points I chose for the line. Okay, and then you're going to press Stat again, and then you're going to go over to Calc, and for LinReg, you're going to choose option 4. Stat Edit, Stat Calc 4 for LinReg. Okay, so now Stat Calc 4 for LinReg. And you can store the equation if you want to by pressing alpha trace 1. And it'll store that equation in Y1 for you, and then press enter. And so here they say A is 2. They're giving you Y equals AX plus B, and A is 2. And B is -4. So Y equals 2X minus 4 would be my equation. And now for quadreg, we're still going to do Stat Edit. We got to put this table in. And then we're going to do Stat Calc 5 for quadreg. So Stat Edit. And we already have 2 of the points. We just need to add that third point. Okay, and then now we're ready. Stat Calc 5. Okay, and so here they're giving us ax squared plus bx plus c. So y equals 2x squared minus 8x plus 4. They're giving me the a, b, and c values. They're always going to give you the equations in standard form, and then for LinReg, they're going to give you slope-intercept form. Okay, and then to find the solutions, we already have it. 1, -2 would be this one of the solutions, 4, 4. And it says, state the interval where the quadratic is less than the linear. Okay, and so quadratic is below the linear between the two solutions. Okay, and so between the two solutions would be between 1 and 4. So my interval is 1 to 4. That's interval notation. In inequality notation, we would say x from 1 to 4. That is where my quadratic is below the line. And you'll see why we care about that in this next application problem. Okay. Okay, and so here it says a photographer specializes in taking senior portraits. I'm going to clear this. A photographer specializes in taking senior portraits. She records the amount of revenue she earns for the senior portrait packages that she sells. So here we have the number of portrait packages. Here we have the revenue. It says use a quadratic regression to write an equation to model the photographer's revenue. Okay, and so we're going to get our calculator. And we are going to stat edit. And then stat calc 5 for Quadratic. So stat edit. And then you can go up and highlight the L2 and press clear. Go up and then enter. And then L1 clear, enter. We can type our new data. So 5, 10, 15, 20, and you need all the points. If they give you data, use all the points. And then and then stat calc 5. They're telling me A is -1, B is 120, C is 0. So my quadratic equation would be y equals, A is -1, so negative x squared, B is 120, plus 120x, and then you could write the plus 0, but we usually leave it off. All right, so there's our quadratic equation. Each month, the photographer must keep track of her costs and revenue. Her costs consist of a fixed amount of $1,400, which includes rent, utilities, and worker salaries, as well as $30 per package to print the portraits. Write a linear equation to model this cost. So our slope would be 30 because it's per package. And then the fixed amount would be our y-intercept. That fixed amount means it's not changing, so just 1,400. Okay, and so now we have a linear quadratic system. So it says determine the amount of portraits the photographer needs to sell in order to make a profit. Is this solution reasonable? Okay, and so I have a quadratic here. We know it's opening down because of the negative a value here. And then we have a positive slope for our line. And so when we graph this, we should find 2 intersection points. And then we want to know where she's making a profit. And so in order to make a profit, we need this revenue function to be higher than the cost. Okay? And so that is going to be between the roots. That's where our revenue is above the line. So this whole area here would be her profit, okay? And so she would be making a profit between our 2 solutions. So once we find these solutions, we just need to put their x values. Okay, and so I'm going to graph this system. And so in y equals, I'm going to have negative x squared plus 120 x, and y2, I'm going to have my 30x plus 1,400. Okay, and then when I press graph, you're going to want to change your window quite a bit. And so looking at my table, my x-min, since we're talking about portrait packages, we don't really need to go into the negatives. And then it's going all the way to 40 here. And so I would go to at least 40 on your graph. We may need to make that bigger. For our Y minimum, we're gonna start at 0 because we're talking about revenue. And then for the Y max, on our table, it goes to 3,200. So I'm gonna type in like 3,500 and see how that looks. Okay, and so here it's hard to see my graph clearly. And so I think editing the X values to go further would be the best. And so let's change that to maybe 100. Okay, and so maybe change the Y max to be a little bit bigger. Say 4,000. And so here I can see my intersections more clearly. So now when I do second trace 5, for my left bound, I'm gonna move the cursor to the left of my first intersection point. So just using the left arrow. Press enter. Move to the right of your intersection point. Press enter. And then your calculator will tell you to guess. So just get close to it and guess. And so for me, it says 22,000. And so this first X value is 20. And then now we're gonna do the same thing for the second intersection. Second trace 5, you gotta do those options again. And then for my left bound, I'm still gonna be to the left of the second intersection. And so maybe about here at the 60. And then for the right bound, make sure you're to the right of the intersection. So keep pressing the right arrow, enter. And then to guess, just get as close as you can and press enter one more time. And then it'll say your intersection. And for me, it says 70 for my X value. Okay, and so to answer the question, she would have to sell between 20 and 70 portrait packages to make a profit. So between 20 and 70 portrait packages.